Okay, so there were really two ways to solve this problem. Okay, so what Rob did up here was absolutely 100%, I think, correct. So what we're giving the original problem, we're giving how long of this projectile was shooting. But even before that, Rob did. I would actually just start off with a diagram, try to visualize what's happening. And I actually, in my last class, I actually drew airplanes. Pretty cool. Flames coming off my projectile. This is an awesome piece of work, right? But the idea is get a visual picture and try to get your triangle in there. So what Rob's done here, I think, is A is where the projectile is being shot from. B is the first plane?
Yeah.
Okay. So is he shooting from A to B? So I didn't actually give you a distance, but I gave you how long the missile traveled for and how fast it was going. So we have speed and time, you get distance. So that's what Rob calculated for one side of the triangle. We got the distance of 1, got 35 degrees, which is the angle in between, right? It's just turning his projectile launcher. And then he shot it, and he calculated it as 409 meters. So we just got our two sides of our triangle, our angle in between. And then it's just a matter of going through the cosine law, plugging in all the numbers, and hopefully at the end you got something like 243 roughly meters apart. Okay. If this wasn't a word problem and you just had a diagram, but we labeled the sides with units, what does your answer have to have? Units. Okay. So you need to be clear on your answering the question exactly. So that's one way to solve it. Another way to solve it is you could actually just use the numbers 2.5 along this side. So I'm gonna, one thing you didn't do, Rob, I'm gonna do for you. I'm gonna label the sides. I'm gonna label the sides. There we go. So that's C. This is. I should have rebooted my laptop this morning. A, and then B. Okay. So for side C, whatever. For side C, you could actually use the number 2.5. So side B, you could actually use the number 3.5. And then what was the number you got across, Demetrius? For A? 2.0. So you could have got, using those numbers to figure for A, you would have got 2.05. What does that number actually mean? 2.05, if you solve it that way. The seconds in between if what?
We're traveling 134 meters.
Yeah. So if this plane had the same projectile launcher, shot it at the other plane, it would have taken 2.05 seconds. And from that second, you could use how fast the missile was traveling, and then you could calculate the same distance. Okay? Either solution is acceptable. In fact, I actually like the other solution better because you actually have to actually understand what all these numbers actually mean, which is pretty cool. Any questions on this? So another question, if it shows up. Okay, I want you to solve this following triangle now.
What do you mean solve?
Solve, so what does solving the triangle mean?
On the side.
All the side lengths and all the angles. But how can we use the cosine law? I mean, cosine law will figure out side lengths. Yeah, we don't have an angle to work with.
But we have the A squared on the other side.
Oh, so was it, do we really have? Was it that we really have then, Demetrius?
Everything.
We have all the side lengths.
Yeah.
So we know A, B, and C, all the lowercase. So we could use that to figure out the angle. So really, this is an exercise in algebra using the cosine law. So let's start off. First thing I want to do is I want to label my triangle. So A, B, C. So that makes this B, this makes this C, and this makes this A. So which angle do we want to solve for first? Okay, someone choose one.
A.
We'll start with A, go alphabetical, right? So cosine law means that if we know that angle, we want to find the other side. So here we know the angle, so we're going to start off the other side as sort of like our unknown, or the left-hand side of our equation, a squared. So because we want to find big A, we want to start with little a squared is equal to b squared plus c squared minus 2bc times the cos of A. And now we just go in, plug in our numbers. So A is 12, so 12 squared is equal to B squared is 8, or 8, B is 8, C is 13, minus 2 times 8 times 13. Boy, it's really hard here. Cos of A times cos, but A is, yeah, we don't know what A is. Okay, so as Mo said, we just want to isolate for cos of A. Yes, Adrian?
Should we round our angles?
Round to point, if we don't, round to 0.1 for angles, 0.2 for sidelines in general. Like if I don't specify the question, I'm going to be obviously more lenient in the mark. Okay? You know what, let's just make it simple. In general, just round it to 2 decimal places. Nearest 100 all the time. Okay, we don't specify.
How do you isolate the cosine?
Well, let's go through that. Okay? So you almost treat like cos of A as like a variable x. You need to get it by itself first. So if this was equation back in grade 9, we had x there, we need to not get rid of, but we need to take care of our additions first and subtractions. So how do I sort of get rid of 8 squared and 13 squared on the right hand side? Please do not say move. Katie?
Subtract them.
Yeah, I want to subtract them on both sides. So if I subtract this, I got 12 squared minus 8 squared minus 13 squared. Now that's equal to negative 2 times 8 times 13 cos of A. Now notice I didn't do my squaring right away. It's a lot faster for me to write 12 squared than 144. Or especially if these numbers get bigger, right? Like for example, the last question, when we had like 326 or whatever squared, we got some 6-digit number. If we save that towards the end, we'll save on copying mistakes. Now that I got everything all sort of isolated, I can actually do the algebra here. So I got 144 minus, or the arithmetic, sorry, 144 minus 64 minus 169. And what's 2 times 8 times 13? 16 times 13? Help me out. 208. So that's equal to negative 208 cos of A. So 144 minus 64 gives me 140 minus 60 is 80. Minus 169? Sorry, minus 69?
Minus 80.
Minus 89. That's what I need to calculate. Minus 89 is equal to negative 208. That's the cos of A. Right, so I just did the arithmetic on the left-hand side now, and do the multiplication of my constants on the right. Not the constants, the coefficients on the right. Now how do I isolate for cos of A?
Plus 208. No.
Well, I had a negative 2 here, right?
5 minus 208.
Yeah, so I want to divide both sides by negative 208. So 89 208. Just got rid of my negatives. The cos inverse of that is equal to A. So the cos inverse of 89 divided by 208 is, sorry? 66? Roughly? Okay, so A is equal to 64.66. Okay, so just an exercise in algebra using the cosine law to solve for an angle now. So we need to be given all three sides. Now we can figure out an angle. So let's go on to angle B. Do the same thing. Right? Do the same thing. Take your cosine law. See a lot of not heading. Yeah, we just use sine. Remember, now we're looking at another problem, but we have another piece of information. So going back, can I use the sine law now? Yeah, sine law makes our lives easier. The algebra, the arithmetic is a bit easier with it. So now that we know one angle, in this case, big A, and the opposite side, little a, we could use the sine law to get the other angles. So let's look at, Demetrius wants to find C really bad. So we get sine of C over little c is equal to sine of A over little a. So again, the little trick with the sine law, if we want to find the angle, we put the signs on top and the little letters on the bottom. And that'll make the algebra easier. If we're solving for the side, we want a little length of a side. We put the little letters on top and all the signs on the bottom. So here sine of C is equal to what's little c? 13. It's equal to sine of A, which is 64.66. All over A is 12. So sine of C sine of C is, what happened to my head? 12 there, right? 13 times sine of 64.6 all over 12. So what's the sine of C? So sine of C is 0.97.
Oh yeah.
7, 9 roughly. So C is 78.13.
Yeah,
1213. Could be a rounding issue. That's fine. And finally, we need angle B. So how do we get angle B? Nice. So again, I could go back to the cosine law. I could use the sine law, but the easiest one of all, if we know two angles, how do we get the third? Yes.
Define pretty much sine of C to C is that you just did the inverse.
Inverse sine, yeah. So the opposite of sine is the inverse sine. So once you got 0.979, you want to do the inverse sine of that. Okay. So angle B is equal to 180 minus angle A minus angle C. So that's 180 minus angle A was 64.66 minus 78.13. So what is that? Okay. So that's how we get the rest of our angles. So notice that we used three different techniques to actually solve this triangle. But we went from very hard, the cosine law, to gradually easier because we have additional piece of information using the sine law, and finally get a straight arithmetic. So if you were given this question on a test, that's exactly how I would approach it, because you could do it faster that way. If you find you're done at the end of the test, you want to check. I wouldn't redo the arithmetic. I would probably do angle B using the sine law. Just as additional check, do I get the same answer? Because at least angle B, I have to use the other two sides now, and then I might have got a different answer somewhere. And that may be a red flag, an error somewhere. But get it done first. This is one way you can sort of double check your work once you have time at the end. Okay? Any questions? That's it for this unit. Sine law, cosine law. Two ways to use the cosine law. Finding a side between, opposite an angle that you know and two other sides. And solving for an angle. After this, it's just
Review.
solving problems. In other words, word problems. But all the skills are there, right? And we have a review and then the test. You guys have your test next Friday. So this is a homework. Got the rest of the class to work on it.